Okay. Oh. There we go. Beautiful. Okay, let's go ahead and close that real quick. Close that real quick. Okay. Okay, I think we're good. Garbage. First of all, what we need to do is, I wish I had an actual webcam I could hold, but these are my parts. Lots of connectors, other junk. This. Oh no. Am I hooked up in here? It is not. Might end a little bit prematurely if I can't find a hookup. I think I have one here. Okay. Yep, there it is. Beautiful. Okay. Ta-da! Okay, I'll get up to the computer. Okay. And I was going to set up a display capture real quick. Yeah, go ahead and pull that out first. Don't need that right now. Let's go ahead. Don't be a pain. Thank you. Take that. Grab this. Let's go over there. It's for gaming, which I'm definitely not going to be doing right now. Okay. Where? Oh, do I have screws? I do have two. Okay. Whoops. Where's my screwdriver? Ah, I should have definitely have a screwdriver. Let me go grab one. Ah, it's flat there. Doofus. Forgot I have a screwdriver here. Let's see. I need a Phillips. There it is. Okay. Whoop. Pull up my pants like a big boy. Okay. So this right here, I'm going to take, oh, you can't see it. I'm going to take this Uno board off here. This was a very old project. It was just a kit, and it worked, but it didn't work because I didn't know how to code. I still don't. So, actually, the whole goal of this stream is to learn how to code live, because I figured, why not? If I'm going to learn how to code, I lost a screw. They're plastic screws. Fatty. Then I might as well do it live, because content is content, no matter what it is. This board is also pretty dusty, and it is an Uno, Arduino Uno, by Osoyo, which I believe is a Chinese company, which, you know, doesn't really make a difference, except for the fact that the board, I do not believe, has any working code on it. However, it does have quite a bit of code for moving this car, like actually just moving it forward. Oh, is this? Stop being a pain. Oh, the screw's not turning. There we go. no. Oh, you gotta be kidding me. Okay. Hold on, let's try this. I wish I had another camera. So this wasn't just me sitting here where you couldn't see anything, messing with a board that you can't see. Okay. There's the board. Let me get this last little screwy bit off here. Oh. Ah. Okay. There's that. There is the board. Oh, geez. I wish that light back there wasn't in the way. So there's the Uno. Okay. Let's go ahead and get this hooked up. And I have. Ooh. I just want to make sure this doesn't flop around a bunch. So we get it plugged in. There we go. Like that. It's not what I wanted it to do. It's actually exactly the opposite of what I wanted it to do. Just stay right there. Okay. Let's see if I still have audio when I switch. There we go. I still have audio. Let's go ahead and delete that one. And delete. Oh, I can't. Oh, there it is. That one. Okay. And we're going to go ahead and add display. Display capture. Yes. Capture the monitor. Can you? Doesn't look like you can. Okay. Well, we'll add. We'll try. Brown. No. Okay. Window. Window capture. Explorer.exe. No, that's not it. Let's go. Can we? Okay, we can capture this. We can capture this. This. Oh. And oh, okay, that's not a thing. Okay, so hold on. Bear with me. It's just a pain. Can I just edit this? Oh. Oh, okay, there we go. It's not gonna let me open Chrome. Does it have to be on this page? Fusion. Oh. Ah, this is okay. Okay, well, hold on. If I go game, maybe. Add a new source. No. Any full screen application. So you're gonna capture that. Oh no, okay. Capture a specific window. I can capture that, which is really just not lovely. Hotkey. What's the hotkey? I don't know. Ah! It's just painful. Why will it not just let me capture Chrome? Why can I not just get Chrome? You know what? I guess you just get to see my beautiful face. Okay, we are gonna go Arduino IDE software. Okay. Arduino IDE Windows 7 and newer. Oh, hold on. Can I get it here? There we go. Oh, I can get it through Microsoft Store. Like I want to do that, definitely. Not a fan of the Microsoft Store, just gonna say. Sorry, Microsoft. Not a fan. Yeah. Okay, beautiful. How big is it? Hopefully not big. 200, oh, 203 megabytes. That's, too large. You know, coding basics. Because like I said, I have never coded Arduino before. Official tutorial in arduino.cc. Okay. Sure, buddy. Give me that. Oh, Arduino IDE is just installed. Beautiful. Launch it. Okay. Access. Ooh. Ooh, okay. Wow. Serial. Arduino 1.0. Okay. Beautiful, but where is my... Yeah, sure, I don't care. Yes, brand new to Arduino. Connect the board, it says. Oh. Yes, this is what I want to do. Okay. You're just gonna have to deal with that light up there because... Okay. Okay. Standard USB cable A, plug to B plug. The Arduino Nano, A to mini B. Okay. Okay. Download the Arduino software. And I'm going to auto drive USB or an external power supply. If you're using an Arduino Decilema, you'll need to make sure that the board is configured to draw power from the USB. Power source is selected with a jumper, a small piece of plastic that fits onto 2 of the 3 pins. USB and power tracks. Make sure that it's on the 2 pins close to the USB port. Connect the Arduino board to your computer using labeled power should go on. Okay, beautiful. Oh, this is why I wish I had a second camera so that you guys could actually see the Arduino board here. Let's stick you over there for now. Okay. Silly cord man. Stop being a silly cord man. You just sit correctly. Thank you. Okay. Power is on. Installing drivers. Plug in your USB and wait for Windows to begin its driver enter. Despite its best efforts. No. Oh, okay. Okay. Click on the Start menu and open up Control Panel. Oh, did we just chop frames or something? What's going on? Why did my camera just turn back on? Please tell me I don't have to be on. Hold on, if I go over here, open this overlay. Okay, you're good. Good. Beautiful. Okay. Now that's in the way. Why does cable management have to be such a pain? Okay. Let's go ahead and close that for now. Control panel. Control panel. Where's control panel? You know what? We will just search control panel. There we go. While in the control panel, navigate to System and Security. Click on System. Oh, just Device Manager? Just go to Device Manager. Okay. System. Oh, there it was. Device Manager. Okay. Look under ports, COM and LPT. You should see an open port named Arduino Uno. Ports, COM and LPT. Arduino Uno, COM4. Yes, beautiful. If there's no COM, look under other devices. Right-click on the Arduino port and choose Update Driver Software. Next, choose the Browse My Computer for driver software. Navigate. Located in the drivers folder of the Arduino software download. Old version of the IDE. Choose the Uno driver file named Arduino Uno. Okay, Windows will Photoshop the driver installation. Okay, so choose Browse My Computer. Update driver. Browse My Computer. Where's that gonna download? Will that just be in downloads? Let's check. Doesn't look like it. Where does it say it's gonna be? Oh, why are you such a pain? Let me see this. No. Where did it go to? What? Cool. Yes. Arduino, yeah. Okay. Let's see. Okay, hold on. I have an idea. Let's go to here. Fusion. Oh, I got it from Microsoft Store. That's right. That's right. Where did it go? Installed. IDE. Can I go to? Where's the? Where does it download to? Oh, you know how much pain that is. Oh my goodness. I should have just downloaded it the other way. Start. Can I not open it? I can't open it. Where is it? It won't even tell me where it's stored? Do you even know? I don't want you to open it. Oh my goodness. Where is it? It's in temp. App data local to. Okay. Bye. Save. Save in Arduino. Documents. Documents? Ah, that was. Do you know how much more annoying that was than it should have been? Where to find the freaking thing? Arduino. Arduino data. And it's still not even there. Are you serious? Are you serious? Okay. Okay. Arduino Uno drivers. Okay, yes. Navigate to the folder. Where's the folder? Okay, then just give me the... Okay. 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 You know what? And then sometimes I just get my internet just poops on me, and that's so confusing. So I'm probably dropping frames, or not. I don't know. It'd be really nice if I could actually get a capture of Chrome, but apparently, Streamlabs doesn't want to do that. So, add a source. VR. That would be pretty cool if it worked. Window. Browser. Does that work? Can I just add a browser? Sure, I don't care. Whatever. Add it. No, that's not what I wanted to do. That's just a web page that it pulls up on it. Okay. Take me to the page. Download the Arduino software ID. Yes, beautiful. Get that, please. Download page. Let me. Zip file. Just download it. I don't care. Just give it to me. I just need the drivers. I just need the drivers out of it. And OBS is still really, really upsetting me. Okay. Let's go ahead and get rid of that. Okay. Edit. Okay, so why is it not actually capturing the display? It says display capture, and it's just not. It's just not capturing it. I don't know why. I don't know why it's not capturing it. Ah, Chrome. Oh, there it is. Hey, Chrome.exe. Let's go. It'd be really nice if we could just capture my display, but you know what? We're good. Okay, this is downloaded. Arduino drivers. Okay. And let's go back, actually. Let's go ahead and just grab all of this. I don't think you can't see anything up in front of it now, just the Chrome screen. Okay. Grabbed it, close that, go over here. Just go paste it into downloads. You wanna do that? Start files. Okay. Just please. Just unzip. Just unzip. Okay. Thank frickin' Lee. Browse my computer for drivers. Browse. Downloads. Arduino. Drivers. Hold on. Now we gotta go back over here. Way back over here. Okay. Choose browse my computer. Navigate. Not located in the drivers folder. Arduino.inl. Okay. Drivers. Yeah, I'm not seeing that. I'm not seeing anything labeled Arduino.inf. Oh. Hey, Becca. What? No, go.
Why?
Because I'm trying to code.
Please. Can't you go later?
Oh, wait. Hold on. Where's my history? Open it back. Yeah.
Are you talking to someone?
I'm streaming. Windows. What? No, go, please. Oh, okay. Launch the Arduino application. If your Arduino software loads in the wrong language, you can change it. Okay. Open the link example sketch. Okay. So now it'd be really nice if I could actually capture window capture. Maybe that'll work. Window capture. Where's my window? Where's my window? No, new source. Okay. Beautiful. Okay, I can. Beautiful. Okay, so let's go ahead and hide this one. Boom. Let's go ahead and grab this one. Pull it up to size and center it. Oh, actually, I'm gonna bigitize it, and it's probably gonna screw it all up. Yeah. Okay. Whoopie doo. Bop. Bop. Okay, so this is my Arduino code. So we're gonna go ahead and hit open. Look in this PC, downloads, this one, examples, basics, I guess. Back. How do I go back? Examples. Display. No. Wait, hold on. Light there, man. Ah. Do you know how annoying this is? Honestly, do you know? I wish I could just. I wish I could just scree. Bare minimum. Blink. That's probably it. Oh, okay. Which one can you see? The big one? Okay. Let's go ahead and edit this window capture. Yes. Okay, beautiful. Now, you can close this big one. And it still found that one. Okay, beautiful. Beautiful, boy. Let's go ahead and bigitize it. Should still be there. Yep. Okay, so here it is. Turns on LED for 1 second, then off for 1 second repeatedly. Most Arduinos have an onboard LED you can control. On the Uno, Mega, and Zero, it is attached to digital pin 13. Digital pin 13. Okay. On your if you want to know what pin on the board LED is connected to, and you know, check the technical specs of your board. Modified, yada yada. This example code is in public domain. Run the power or reset on the board. The board void setup. Initialize digital pin LED bulletin as an output pin mode LED bulletin output. The loop function runs over and over again forever. Void loop. Digital write LED button high. Turn the LED on. High is the voltage level. Delay 1000. Wait for 1 second. Turn the LED off by making the voltage low. Wait for 1 second and then it loops. Okay. Okay. Let's go back over to Chrome. You'll need to select the entry in Tools Board. Okay. Tools. Board. Arduino Uno. Beautiful. Select your serial port. Select the serial device of the Arduino board from Tools Serial Port COM3 or higher. That's going to be COM4, right? That's what it was. Tools Serial Monitor or Serial Plotter, I think. Oh, it's not. Okay. Port. COM4. Okay. Back over here. To find out, okay. Now simply click the upload button in the environment. Wait a few seconds. You should see the RX and TX LEDs on the board flashing. If the successful message done uploading will appear in the status bar. Note you have an Arduino Mini and GR. Only just physically press the reset button on the board immediately before clicking the upload button. A few seconds after the upload finishes, you should see the start to blink in orange. If it does, congratulations. Okay. And the board starts blank. If it does, congratulations. You've got no Arduino up and running. If you have problems, see okay. Okay. Let's click the upload button. Upload. Save. Done. Compiling. An error occurred while uploading. COM4. Can't set the COM state. Okay. Troubleshooting suggestions. Sure. Hardware. Upload. Can't set COM state. Okay. We are gonna go. Oh, Arduino Uno. No, not the Arduino Uno. Oh. Martha, what are you doing back here? Okay, where's my reset button? Is that it? I need to hold it? Okay. Reset the board. Try again. Can't set com state for 4. Okay. Boom. Boom. PID. Oh, okay. So it can find it, but it's not. Oh, it's not receiving or transmitting anything now. Okay. Let's go ahead and unplug it. Let's go ahead up here. Port. Okay. Done. And then we plug it in. Okay. Okay, that is actually what it's on then. Reset the board. Upload. Currently sketch. Oh, I got it to work. Okay. Okay. I think it worked. Hold on. Let's switch to looking. It's working. I'm happy. The LED is blinking on and off. Yay. That only took 38 minutes to get an LED to blink. Okay. Alrighty. Let's go back over here. Let's go ahead and hide that one and hide this one. Okay. So, done. Let's go back over here. So, getting started. Install. Learn Arduino. Yes. Learning. Tutorials. Getting started. Built-in examples from your library's foundation. The key elements and software and the concepts behind it. What is a sketch? What are microcontrollers? Ooh, okay. We'll do that in a minute. But right now, let's read all of this. Foundation circumstance more some basic knowledge about the principles and techniques that are behind the Arduino platform. Okay. If you want to get some knowledge before you start using things, this is the right place. Okay. Introduction to what's the Arduino board autonomy. Okay. We're gonna open all of these. No, I don't need ID. I already have that. But let's go look at this. Okay, what is Arduino? Arduino is an open source electronics platform based on easy to use hardware and software. Yada 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 yada. Why don't insert a finger on button on Twitter message? Entering into an output, activating a motor, turning on an LED, publishing something online. You can tell your board what to do by sending a set of instructions to the microcontroller on the board. To do so, you use the Arduino programming language based on wiring. Okay. What's and the software IDA based on processing. Okay. Over the years, Arduino has been the brain of thousands of projects, from everyday objects to complex scientific instruments. A worldwide community of makers, students, hobbyists, artists, programmers, and professionals has gathered around this open source platform. Contributions have added up to an incredible amount of accessible knowledge that can be made. Arduino was born at the yada 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 yada. I don't need that. Inexpensive yada yada. Okay. How do I use? Okay. So I'm done with that. That was just yada yada. Language reference functions. Oh, we'll need to leave that open later. Wiring. Wiring. Oh, it's just okay. Bye. Don't need that. Oh, processing is also. Oh, okay. So those are both just programs. Gotcha. Alrighty. Arduino board sends the environment by receiving inputs from many sensors and affects their surroundings by controlling lights, motors, and other actuators. They didn't spell effects right. Arduino boards are the microcontroller development platform that will be at the heart of your projects. When making something, you will be building circuits and integrations for interaction, telling the microcontroller how to interface with other components. Here is the anatomy of Arduino Uno. Use these pins with digital read, digital write, and analog write. Analog write works only on pins with the PWM symbol. Oh, digital PWM, that's all the ones on that side. Power analog in. Okay. Makes sense. Okay. The only actuator built into your board, besides being a handy target for your first Blink sketch, the LED is very useful for debugging. Oh, okay. Indicates the Arduino is receiving power. AT Mega microcontroller. Hold on. 2, 3, 4. Where's 4? Oh, that's a micro. That's why it's so big. Probably makes sense. Okay, gotcha. Analog in, use these pins with analog read. G and D and 5-volt pins. Use these pins to provide plus 5-volt power and ground to your circuits. Oh, okay. Yeah, that's the power port. Got it. GX and RX light and your computer expect them to flicker rapidly during sketch upload as well as during serial communication. Used for powering your Arduino Uno. Oh, my sketch is still running over there. Uploading your sketches to your Arduino and for communicating with your Arduino sketch via serial print and etc. Resets the AT Mega microcontroller. Oh, text. I'm gonna make sure that's the right button. 10. Okay. Okay, so it's actually super stinking simple. Very, very simple. One sketch, let's go ahead and close sketch. And getting started with Windows, Mac, you uploaded a sketch that blinks an LED. And this is well, you're going to use each part of a sketch. The first few lines of the blink sketch are a comment. Blink, basically. Everything between the yada and the yada is ignored by the Arduino when it runs the sketch. At the start of each line is only there to make the comment look pretty. Oh, and it isn't required. Okay. I was like, why is it? It's there for people reading the code to explain what the program does, how it works, or why it's written the way it is. It's good practice to comment your sketches and to keep the comments up to date when you modify the code. This helps other people learn from or modify your code. There's no style for short, single-line comments. These start with / and continue to the end of the line. For example, and the line LED connected to digital pin 13. The message LED is a comment. Okay, be quiet. I'm not supposed to be amazingly variable. Yes, okay, the whole point of coding streams is that it's just boring, and it's just me not knowing anything and learning. I'm just storing a piece of data. It has a name, a type, and a value. For example, the line from the blink sketch above declares a variable with the name LED pin, the type int, and the initial value of 13. It's being used to indicate which Arduino pin the LED is connected to. Every time the name LED pin appears in the code, its value will be retrieved. In this case, the person writing the program could have chosen not to bother creating the LED pin variable and instead have simply written 13 everywhere they needed to specify a pin number. The advantage of using a variable is that it's easier to move the LED to a different pin. You only need to edit the one line. Oh, okay. Often, however, the value of a variable will change while the sketch runs. For example, you could store the value read from an input into a variable. There's more information in variables tutorial. We'll open that one as well. Okay, so technically, I have done what I set out to do, but I'm now trying to do more because I have completed the goal, which was to get this little LED to blink, which it did. But basically now I'm just going to go through and read all of this stuff, which is extremely boring and probably does not need to be on a stream because I'm just going to go learn how to, I'm just going to go learn how all of this stuff works. But I am going to code sometime soon. I'm actually going to try to sit down and code stuff from the computer to the Arduino, get it to do things, because also, as well as that, this car has a ton of different sensors and whatnot, and I also have this kit which I purchased. It has its own Arduino because this one I didn't know if it was actually going to work because it's old and it never worked for me originally. And we also have a Do, an Arduino Do, which is I thought it was fancier. I guess it's actually not. So I think it's actually an older board, but it does have this big microcontroller, and it has tons more pins. So it may be more advanced. It may just be basically an Uno but bigger. I'm not sure, but that is the Do. I also purchased that. Oh, go in there. Okay, and then we have this thing, which is just like 37 different sensors. I was just like, I might use those for whatnot. And then I also have 10 of these little servos. They're just servos. Right now, that's all I have. But you can do a lot with just servos. So I need to think of a project to do, because now I've got the pieces, and off stream, probably because it's boring, I am going to learn how to actually get this to do stuff. I'm going to learn the language, and then on stream, I'm going to sit down and mess around with code for like a long time. Try to get it to actually run something, and then, yeah, something other than the LED pin flashing, I guess. So what might be a good idea right now, actually, is to go over here to Arduino and just see. Okay, this is what I don't get. As an output, initialize digital pin LED bulletin as an output. So does it say it's a pin mode? Oh, so this is a comment. Pin mode LED bulletin / output, or comma output. Okay, so this is still confusing to me. Right here, a function. Okay, is an area that can be used. For example, here's the definition of the setup function from the blink example. So setup, this is like before it runs it, I guess. First line provides information about the function, like its name, setup. The text before and after the name specify its return type and parameters. These will be explained later. The code between that and that is called the body of the function. What the function does, you can call a function that's already been defined, either in your sketch or as part of the Arduino language. For example, the line pin mode LED pin output calls the pin mode function, passing it to parameters LED pin and output. These parameters are used by the pin mode function to decide which pin and mode to set. For example, the line calls the pin mode function, passing it to parameters, LED pin, and output. Okay. These parameters are used by the pin mode function to decide which. Okay. The pin mode function configures a pin as either an input or an output. To use it, you pass it the number of the pin to configure and the constant input or output. Oh, okay. So, pin mode. The LED pin, that one that we have already, is going to be output. And then it's always constantly output, or what? Or like that's just when you put the function to use it, you pass it the number of the pin. When configured as an input, a pin can detect the state of a sensor. This is discussed in a later tutorial. As an output, it can drive an actuator, like an LED, I guess also a servo, probably. Digital write functions outputs a value on a pin. Functions outputs a value on a pin. Digital write LED pin high sets the LED pin 13 to high, or 5 volts. Writing a low to being connected to ground, or 0 volts. Oh, okay. So digital write is actually how you tell the pin to do things, I guess. The delay causes the Arduino to wait for the specified. So most everything is just going to be setting stuff to high voltage to change things, right? Delay causes the Arduino to wait for the specified number of milliseconds before continuing on to the next line. There are 1,000 milliseconds in a second, so the line, creates a delay of 1 second. There are 2 special functions that are part of every Arduino sketch: setup and loop. Setup is called once when the sketch starts. It's a good place to do setup tasks like setting pin modes or initializing libraries. The loop function is called over and over and is heart of most sketches. You need to include both functions in your sketch, even if you don't need them for anything. To actually make the sketch run, you need functions. Setup and a loop. Yeah. So for this one, setup didn't do anything at all. Okay, makes sense. And I believe if you open a new sketch, so let's just go new. Yeah, look, so it says void setup and void loop. So I'm not sure, that probably didn't show up for you guys. But oh, exercises. Yes, this is exactly what I wanted to do, actually. Okay, change the code so that the LED is on for 100 milliseconds and off for 1000. Okay, digital write LED, but wait for 100 milliseconds. Off for 1000. Done. Okay, reset the board. Beep. Beautiful. Oh, do I have to hit upload first? Okay, this is pretty cool. That's the first time I've ever done anything with code, because the other one was just loading the example code. And okay, change the code, turns on when the sketch and stays on. Okay, digital write LED button high, digital write LED button low. Right? Oh, but now I gotta end it. Where's my... yes, okay. And then that should just... No, we gotta remove delay as well. Yeah? Won't that just set it to high? Let's try that. Okay. There you go, now it's just on. I did something! Oh my goodness. That makes me so stinking happy. Okay. Okay, good. That's beautiful. See also, hold on, let's see what it says. See also, oh, okay. Arduino. Variables. This is the stuff I really wanted to look at here. Can you, oh, you can't see that. Whoops, there you go. Now you can see it. Okay. A variable is a place to store a piece of data. It has a name, a value, and a type. For example, this statement called a declaration. Initialize pin. No, wait. INT, but hold on. Does this actually initialize digital pin LED bulletin? Oh, okay. So on this Arduino, that is just called LED bulletin or built-in LED. I've been reading that wrong. LED built-in. Pin mode, LED built-in output. So these other ones that are actually labeled here, we have 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh, digital PWM has a little squiggly. So 11, 10, 9, 6, 5, and 3 are digital PWM pins. Not sure that does anything. Creates a variable whose name is pin, whose value is 13, and whose type is int. Okay, so what is int? What is that type? Later on in the program, you confirm its name, at which point its value... Oh, was that an output, maybe? I don't know. At which point its value will be looked up and used. For example, in this statement, pin mode pin output. It is the value of pin 13 and will be passed to the pin mode function. In this case, you don't actually need to use a variable. This statement would work just as well. Pin mode 13 output. Oh, okay. The advantage of a variable in this case is that you only need to specify the actual number of the pin once, but you can use it lots of times. So if you later decide to change from pin 13 to pin 12, you only need to change one spot in the code. Also, you can use a descriptive name to make the significance of the variable clear, e.g. a program controlling on RGB light might have variables called red pin, green pin, and blue pin. A variable has other advantages over a value like a number. Most importantly, you can change the value of a variable using an assignment indicated by an equal sign, for example, pin equals 12. Most importantly, change the value of a variable. Oh, okay. Oh, like what it said up there. Okay. Change the value. Notice that we don't need to specify the type of the variable. It's not changed by the assignment. That is, the name of the variable is permanently associated with a type. Only its value changes. Note that you have to declare a variable before you can assign a value to it. If you include the preceding statement in the program without the first statement above, you'll get a message like, error, pin was not declared in this scope. So, int pin equals 13, pin equals 12. Oh, okay. Okay, when you assign one variable to another, you're making a copy of its value and storing that copy in a location. Changing one has no effect on the other. Example, int pin equals 13, int pin 2 equals pin equals 12. Only pin has the value of 12. Pin 2 is still 13. Oh, that's confusing. That would confuse me so fast. Now what, you might be wondering? Did the word scope in that error message above mean? It refers to the part of your program in which the variables can be used. This is determined by where you declare it. For example, if you want to be able to use a variable anywhere in your program, you can declare it at the top of your code. This is called a global variable. Here's an example. Pin mode pin output. Oh, int. Okay, so before even setup, and that's just everything. As you can see, pin used in both the setup and loop functions. Both functions are referring to the same variable, so that changing it will affect the value it has on the other, as in int pin. Okay, so hold on. Pin equals 13, pin equals 12. Here, the digital write function called from loop will be passed a value of 12, since that's the value was assigned to the variable in the setup function. If you only need to use a variable in a single function, you can declare it there, in which case its will be limited to that function. For example, pin. Okay. In this case, variable pin can only be used inside the setup function. If you try to do something like this, pin low, wrong, pin is not in scope here. Okay, so it needs to be at the beginning. You'll get the same message as before. Error, pin was not declared in the scope. That is, even if you declared a pin somewhere in your program, you're trying to use it somewhere outside its scope. Well, you might be wondering, wouldn't you make all your variables global? After all, if I don't know where I might need a variable, why should I limit its scope to just one function? The answer is that it can make it easier to figure out what happens to it. If a variable is global, its value could be changed anywhere in the code, meaning that you need to understand the whole program to know what will happen to the variable. For example, if your variable has a value of you didn't expect, it can be much easier to figure out where the value came from if the variable has a limited scope. In some languages like Python, types are associated with variables, not variable names. You assign this is referred to as type. Okay, understand kind of variables. Digital pins, analog pins, PWM, memory. Okay. Here we go. Properties of pins can be used as input. Pins default to inputs, so they don't need to be explicitly declared as inputs with pin mode when you're using them as inputs. Pins configured this way are said to be in high impedance. Input pins make extremely small demands on the circuit that they are sampling, equivalent to a series of resistor of 100. Oh my goodness. Okay, So you know what? I'm gonna go mess with this code some more. I am just going to do this. Delay. Oh, wrong one. Dumb. 50. Boop. Whoops. Digital. Right. What did I do wrong there? Oh, does right have to be capitalized? Oh, I didn't spell digital right. Whoops. Digital right. Does that have to be caps? LED built in. Hi. Oh, no, low. That needs to be low. Whoops. Low. Has to be caps. Low. Okay. Delay. 50. Okay. Arduino man. Reset. Boop. And upload. Oh, does there have to be a upload? Expected. Oh, I put the wrong one. Whoopsie. Okay. That's okay. Don't stress. Don't stress. What did I do? How did I? Where did my digital right go? Okay. Digital right. So that does have to be a capital. That is a pain. Okay, digital right, LED button low. LED built in, sorry. Low. Expected before. Oh, so those just go everywhere. Yeah? Pretty much. So after every line, you just have to put one of those in, maybe? We'll see. Let's go! Look what I did. Hold on. Give me this. See, with that 50 millisecond delay, you get a Blink 182 song. Oh! Okay. And I've been streaming for an hour. I think that is a long enough YouTube video. So, we're going to go ahead, go back over here, new scene. Go ahead and save this because I'm proud of it. Save it. Did it save? I'm going to say it saved. Close it. There you go. Got that capture. Oh, hold on. Actually, hold on. Let me. Where's my Arduino ID? Arduino. Okay, it just opens that one again. New. Okay. Pin mode. Are you getting this? Hold on. Let me. Okay. Let's go ahead and close that one and bigitize this one. Pin mode. Oh, I forgot. That one has to be a cap. Pin mode. Where's my LED? Oh! Okay, I don't care. LED underscore built in output. Okay. Done. Digital right. LED built in low. Oh, whoops. Didn't cap that one. There we go. Oh, okay. Sure. Whatever. So, so do you just have to, every time you run a, what are those, variables? You have to put a, okay, sure. Okay. Look at this. I just wrote a program. I'm amazing. It is literally probably the most simple program ever made. But I'm very proud of myself because it just shut off the LED. Okay. Let's go ahead and close down that. I'm gonna keep reading up on all of my stuff, and I will probably come back and show you me coding whatever I do next. Just with that, and I think that's about it. So thanks for watching the stream, to anyone who is or does in the future, and we will see you next time.